Hello and welcome to my video lab report of Physics 2212 Lab 2, Lines of Charge. The goal of this physics lab is to create a computational model of the interactions between two charged lines of tape. It is similar to Lab 1, however, rather than building it in person and measuring, it is created on a Python script. Some assumptions that we have to take in order to build this model are that air resistance is negligible and that the tape can be modeled as a system of point charges in long. This allows us to create a free body diagram for each segment of the tape in which we have the electric force upward and the gravitational force downward with no other forces acting on it. This allows us to model the interaction. To use our model, some initial values are necessary. In this case, I'm using the initial values found in my Lab 1, in which we created this system in person and measured the differences and such. These values will prove to be a starting point in order to build off of to get a more accurate model. Much of the code is given in the starter pack of the lab. However, you must create the electric field function in order to model the electric field in Python on the bottom, in addition to entering the initial values calculated in Lab 1. The next section of the lab creates lines of charge. However, this is given in the starter pack and no lines were changed. The next step is to create the tape in the computational model. Much of the code is given, however, you must change the Y component of the top tape to the distance that you found in Lab 1 and input a in number, which is the number of point charges that your code will use to calculate the system. The next step is to call upon the electric field vector equation that you created earlier in order to create the model of the electric field vectors for each of the in components. The next step is the creation of the net electric force and gravitational force acting upon the in pieces along the tape. Then it is printed out onto a window in order to analyze with the magnitude of gravitational force and magnitude of electric force. The output of my computation created this image consisting of a system of 30 point charges, each with an electric force from the opposite line of tape but pointing upwards, with the single vector of the magnitude of the total gravitational force heading in the downward. In order to understand this system greater, one must look at the comparison to a single point charge. In this case, we have a system of n equals 2, which consists of 2 point charges of tape acting on each other. You will notice that the electric field force is less than when the system had 30 point charges. That system of less point charges can be compared to a system in which there are 300 point charges on the line of tape. In this case, the magnitude of electric force has increased relative to the system with 30 point charges. Through this correlation between the number of in point charges in the line of tape series and the magnitude of force that varies along with increasing in, one can assume that there is an effect of distributed charge in the distance between each of these charges. It can be assumed that because in real life it is a system of seemingly infinite point charges, that being the atoms with electrons acting on each other, it can be assumed that as n equals infinity, the force of the electric field modeled will equal the true force of electric field that shows in real life. This goes to show that the system in which we analyze electric field and electric force using a point charge system is not always the most accurate when accounting for other shaped objects.